Hi everyone, we are going to go through a 5C or 6C in the extension textbook. Anyway, so 5C for events, 6C for extension. So the topic is 3D trick, probably one of the hardest topics out there. The reason being is really hard to visualize. Well, today I'm going to show you a few tips and tricks how we can approach and solve 3D trick. Well, let's go through what 3D means first. 3D is always start from a 2D plane or 2D object. So let's say this is a surface here. Is not and then we start from there. So I have a point on the 2D surface and I draw a perpendicular plane on perpendicular lines on it. Let's call it AO. Apologize for school gap. Anyway, so I draw a perpendicular line to it called AO. O's start from the center, so I just do AO. And if I draw a rectangle on the bottom, then I can and connect all the corners to point A. Now I got myself a rectangular pyramid. The top of the pyramid, we call it apex. And then the bottom, we call it the base. Because that line is the AO is perpendicular to the surface, it is perpendicular to any line on the surface. That is the difficult concept here. Let's call this B, C, D, E. AO is perpendicular to BC, BE, DE, and CD. That's probably a bit hard to see since they are not even touching each other. The easy one to visualize is BO, CO, DO, and EO. AO is perpendicular to all of those because they in contact. It's easy to see, but that's basically what it is. Pyramids and prisms are the main object that 3D trigonometries are going to use. So those are our main focus here. Okay, I'm going to show you one example here and show you some tricks of it. So I have a question here. It asks to find the exact length of AC and AF. A lot of those questions will scaffold you from the first part to second. If you don't get the first part, the second part probably a little bit hard to achieve. So in this case, we find AC and AF first, and then the second part of it, we ask to find the angle ACF. Well, ACF, FC is perpendicular to CD, which is perpendicular to the plane ABCD. CF is perpendicular to DC, yeah, or BC. It basically means CF is perpendicular to ABCD, the plane. So any line on there is perpendicular. So that means angle ACF is right angle because CF is perpendicular to AC. For part C, find AFC. AFC. So it's on the triangle AFC. We got one right angle triangle already. If we find AC and AF, we can find AFC easily. Like as I said, the question scaffold you for every single part. Let's have a look into the question, how we can approach it. So to find the exact length of AC, let's draw the plane ABCD first because AC is on ABCD. Okay, so let's do it here. So we have A, B, C, D, and we're looking for AC. So we know AB is 4, BC is 2, and we can use Pythagoras. Yeah. So AC squared AC equals to square root of, oopsie, AB squared plus BC squared. Is that right? A squared equals, no, C squared equals A squared plus B squared. So basically the same, okay? So just put in, so we got AB is 4 squared plus 2 squared. So we got square root of 416, that's 20. So is 2 square root of 5, you remember from chapter 1. Okay, we found AC, easy. Now AF, that's I. AF is on the plane of ABEF, so we can draw ABEF first. So AB on the bottom and EF on top. So we're looking for AF. So we know AB is 4 and we need to know BF. We don't know what BF yet. So, but on BF is on also on right angle triangle, and you got 2. Oopsie. Anyway, so you got 2. Wait, that's B, C, F. So we need to work out BF first. BF equals to same trigonometry equation, same Pythagoras equation. So 2 squared plus 2 squared. So, oopsie, well, I jumped the gun a little bit. Is BC squared plus FC squared. So the square root of 2 squared plus 2 squared is 2 square root of 2. So it's square root 8, 2 square root 2, that's right. From there, we can, again, that's 2 square root of 2, yeah. Then again, we use exactly the same method. AF equals to square root of AB squared plus BF squared. Okay, so 4 squared plus 2 square root of 2, bracket square, don't forget bracket. So that is 8 plus 16, 8 plus 16, that is 24. Yeah, square root of 24. Square root of 24, which is 2 square root of 6. Okay, so you find the first part, so part A is done. Part B is what side is ACF. So for B, we can tell that ACF, the ACF is right angle, is 90 degrees. So you can tell by the diagram because FC is perpendicular to AC as a plane. So that's easy. Now C, find ACF, correct the nearest degree. C, ACF, so it's in the same triangle, so we just draw a triangle first. So is ACF, is AC and F. We work out AF is 2 square root of 6. FC is 2. And we want to know what was the angle? AFC. So we're looking for this angle here. So, oh well, we got adjacent and hypotenuse, so it's cos. Oh, we got AC as well, but yeah, that's right, we got those two already. That's okay. So cos theta equals to adjacent over hypotenuse, 2/6. So theta equals inverse cos, whoopsie, 2 over 2 and square root of 6. Timing calculator. Oopsie. I'm just going to do it here. So cos -1. I simplified, so hopefully make it easier. So it will be 60, close to 66 degrees. So theta is 66 degrees. Okay. Oops. Okay. So that's it. We got the angle done. The question is done. So again, it's really well scaffolding question. So it's step by step. Okay. Now I'll give you another one. This probably one of the typical read question that we need to look at. So the angle is everywhere, but if we take it slowly, I think we can find it out easily. So for the first one, is so TA equals to 400 cos 52. So we see 52 here and 400 here. It kind of hints that we're using the triangle ABT. Let's draw triangle ABT first. Triangle ABT here, and we fill out information 400 as AB, and then angle TAB is 52 and TBA is 38. So we got those ones, and we want to know that TA, so TA on this side equals 400 cos 52. Well, cos we need where's that right angle on top? No, didn't say. Okay, sure. We got TA. That means, well, we probably need to use cosine rule, but let's see what this angle is first. Okay, so that angle ATB equals to 180 degrees minus 52 minus 38. Oh, whoa, whoopsie, it's actually 90 degrees. So this is right angle triangle. So right angle triangle, you can use Sukatova. Okay, so when we talk about cos is adjacent over hypotenuse. So adjacent is talk about this angle 52 here. So that means cos 52 degrees equals to adjacent TA over hypotenuse 400. So TA equals to 400 cos 52 degrees. Exactly what it asked for. Done. Okay, next. Find the height of the building, correct the nearest meter. Okay, the height of the building. So the height of the building is H. Another information I didn't put in this diagram is that the angle depression here, because it's not really on that surface, I take it out later. So in this one, we're talking about this triangle here, ACT. Talk about this triangle ACT. So, and we got the angle depression, which is same as bottom. So I'm going to try to draw the triangle first, ACT. Okay, ACT. We work out the AT in the first question is 400 cos 52. We got the angle of depression is 18. So that means the angle on the bottom is also oopsie. Angle on the bottom is also 18 degrees. Okay. We got a hypotenuse, we got the angle, we're looking for the opposite. That's easy, we can just use sine. So sine 18 degrees equals opposite, which is the height, over hypotenuse 400 cos 52 degrees. So the height is 400 cos 52 degrees and sine 18 degrees. So height is, I'm going to bring back the calculator again. So it's 400 cos 52 and sine 18. So 76.1. What does it ask us to do? To round it to nearest meter. So it's 76. So it's 76 meter. Okay. Can I just move it away? Oh, well, we got 76 meter. Okay, I got that. Can't really. Yeah, done. Anyway, so last bit is find the correct newest degree, the angle of depression of B from T. So this here, looking for this angle here. This angle is basically the same as this angle here, isn't it? We know the height here is 76 meter. We just work it out. Yeah. Can we find BT or BC? BC is not given. BT is not given, but BT is basically the same method as TA. Yeah. So from A, TA is 400 cos. Yeah. Okay. Well, let's do that. Similar. If you do BT here, so BT is adjacent to angle 38 degrees. So we can do exactly the same thing. So cos 38 degrees equals to adjacent BT over hypotenuse, which is 400. So we work out that BT is 400 cos 38 degrees. So we got 400 cos 38 degrees. So we got opposite and hypotenuse. We can use sine theta equals to 76 over 400 cos 38 degrees. So we can work out this inverse sine 76 over 400 cos 38 degrees. So let me bring out the calculator again. Would be inverse sine 76 over 400 cos 38. Hopefully it works. Okay, so we work out that the angle is 14 degrees. The nearest minute or nearest degree, yeah, done. Oopsie. So yeah, don't do that to me. Anyway, so yeah, easy. Good. Next one. This one is one of the most typical hard questions you're going to see for 3D trick. It looks really complicated, but I give you some you can pause the video and look at the question first. For me, I'm just quickly skip that. Okay. I did the question already. It looked like B is a little bit hard to get, so I'm going to ask you to skip this bit. So we do A, C, D. Okay. Start from A first. We need to find AT and BT in terms of H. So AT and BT in terms of H. We got the angle. We got the height. Should be able to, and they are right angle triangle, so it should be able to do it. So I'm going to draw the right angle triangle on those two right angle triangle, and then we can start from there. So we draw a drawing here. I really recommend to do a big drawing, but in this case I have limited screen area. I couldn't draw it big, so need to excuse me for that. Now in this case I got two triangles and AFT and BFT. Okay, we're going to use those two to find AT and BT in terms of H. So AT is a hypotenuse here, H is opposite, so we can use sine. So sine 55 degrees equals opposite, height over hypotenuse AT. Similar to this, I'm going to simplify it first. So AT equals to H divided by sine 55 degrees. Okay, similar to the first one. Second one was exactly the same. So sine 40 degrees, because we know opposite, equals to height over BT. So BT equals to height over sine 40 degrees. So that's part is easy. We're going to skip this B, so just go straight to C. Use Pythagoras theorem in BAT to show that H is that. So BAT BAT BAT, so that height is that. He asked us to show BAT, that means that angle is 90 degrees. That one's a little bit hard to show, so we skip that one. We just assume that it's right angle triangle. So, okay. In that case, we want BAT, that means we want, let's say this is right angle triangle. Let's draw it out first. Always a good idea to draw it out. Okay, so we got ABT. If this is right angle triangle, it should be like this. So that means AT. That means AT square plus AB square equals to BT square. So just substitution. AT is H over sine 55 degrees square plus BT is I over sine 40 degrees square because whoops, got it wrong, sorry. Yeah, just going to move it to the other side. That's 50 square, that's AB is 50 square equals that, so H square over sine 55, sine square 55 degrees plus 50 square equals to X square sine square 40 degrees. I'm going to rearrange it a little bit, so 50 equals to I square sine square 40 minus sine square 55. We can factorize the H square. 1 over sine square 40 minus 1 over sine square 5. We find common denominator and then we work out as sine square 55 minus sine square 40 over sine square 40 sine square 55. Okay. If we square root both sides, we should get 50 equals to H. And then times square root of sine square 55 minus sine square 40 over sine 40 sine 55. We square root every single term. Okay, so if we arrange it, we realize H equals to 50 sine 40 sine 55 over square root of square root of sine square 55 minus sine square 40. I'm going to move the homework down a little bit. Move it sideways in here. Okay, so that should be what we got for, yep, that's exactly what we got asked for. And the last bit, D, is just to put in the calculator and H. I think I need a massive calculator for this one. So 50 sine 40 sine 55 divided by square root of sine square 55 minus sine square 40. Being 52. It's 52 meters. Okay, that should be it. Apologize if the answer is not really correct, but anyway, our homework is those questions. Okay, should be fair. Thanks for watching, and hopefully it really helps.